Okay, good morning, class. At this point, you guys had some homework. We're still dealing with equations and inequalities. Just put that there. So, the homework was exercise 4.10. 9. Let's start with 9. Any issues with 4.9? Any issues with 4.9? Right, what is the issue in 4.9? Now can you say yes and nothing is wrong? So no problems with 4.9. If 4.9 if, okay? if. Fatima? Just give that file to me. That is our file. This was on page? Page 88. Thank you. Alright, here we go. So, you can either do it by elimination or by substitution method. Okay? At this point, as you can see, elimination is going to be the easier one here. Not so? Do I need to change the signs on the line? No. So 3x plus 7x is going to be 10x. 4y minus 4y cancel. Negative 24 plus negative 16 is negative 14. Divide by 10 both sides. So x is going to be negative. I substitute into any one of the previous ones. So it's 3 times negative 4 plus 4y equals negative 24. So 3 times negative 4 is going to give you negative 12. So it's going to give you negative 12 there. Plus 4y equals negative 24. So 4y is equal to negative 24 plus 12 is negative 12. Y is going to be negative. Who asked this question? Where did you go wrong? Okay. You understand? Anybody else had an issue with this? That they applied it the other method? Nobody? Okay. Any other problems with exercise 4.9? Any other issues with exercise 4.9? 4.10? So for homework, I want you guys to do 4.9, number 3A, C and E. A, C and E. Let's see what you can do out of that, okay? Number 10, 4.10. Number 6. Sorry, number 9. Which page is this on? Exercise 4.10 on page 93, number 9. If you're allowed to choose 20 coins from a collection of 50-cent coins and 1 rand coins. So we say let the 50-cent pieces or coins equal X. If the 50-cent pieces are X, then the 1 rand coins is then going to be, since there are 20 coins, well, how many 1 rand coins do I have? Okay, make it a bit easier. If there are 5 50-cent coins, how many 1 rand coins must there be? 15. Why? Add up to 20. So you got 5, you get 20 minus 5 is 15. If there was 9 50-cent coins, then how many 1 rand coins are there? 9 minus, 20 minus 9, which is 11. So if there's X 50-cent coins, how many 1 rand coins are there? 20 minus. You understand? So we are then told how many coins must be 1 rand coins if the total value is 15 rand. So how do we get the total? We must say the 50-cent pieces times the amount of 50-cent pieces you have. Not so? So if there's 5 50-cent pieces, then it's going to be 5 times 50, which is 2 rand 50. Not so? 5 times 0,5. If there was 9 50-cent pieces, 9 times 50 cents. Or 9 times 0,5, which is 4 rand 50. Does it make sense? So, if there's X 50 cents, then it's going to be 0,5 times X plus 1 rand. So it's 1 times 20 minus X. It gives you a total of 15 rand. Why did I change this to a half? So we're working in? What is this? Rands. So since we're working in rands, this must be in the rands. If this was cents, then I would have converted the 1 rand to 100 cents. You guys understand? You know there's 100 cents in the rand, eh?
Yes.
So now it's a matter of solving the equation. So it's going to be 0,5x plus 20 minus x is equal to 15 rand. 0,5 minus 1x is going to be negative 0,5x. 15 minus 20 is negative 5. So I divide both sides by negative half. That cancels, so x is equal to 10. Okay. Ever answered the question? No. Remember that x represents 50 cents. So it's x is equal to 10. And your 1 rand, how many 1 rand coins must you have? 20 minus 10, which is also 10. So therefore, 10 1 rand coins. Okay. And you can check if you're right. If there's 10 50 cents, then how much does that add up to? 5 rand. If there's 10 1 rand coins, how does that add up to? 10 rand. And 5 rand plus 10 rand is 15 rand. Okay. The word problem normally comes in for anything between 4 to 6 or 7 marks. Okay. I gave you up until question 11. So for homework, I want you guys to do 12, 13, 14 and 15. So 12 to 15 of exercise 4.10. Then we went on to 4.11. Exercise 4.11. We went into linear inequalities, not so? Linear inequalities, exercise 4.11. You had to do numbers, odd numbers. Any problems with number 135? 135. Yes, Michael? Number 3. Any problems with number 5? No. Any problems with number 7? Yes. Right. Any problems with number 9? Number 11? Number 13? Your homework is going to be exercise was 15 also an issue? You're letting me work for my supper today. No? No problem. Right, here we go. This is exercise 4.12. This is this on page 90. So the question says solve for x. Okay. So what's your LCM here? The LCM is 10. The LCM is 10. So what must that denominator be multiplied by to get 10? 2. So it's 2 into x. Minus. That's over 1, so that must be multiplied by 10. What must that denominator be multiplied by? 10. So it's 2 times 10. And this denominator must be multiplied by 1. Okay, who asked this question? Where did you go wrong? You wrote down the sum wrong. Okay, so I'll wrap it up. I'll do the sum. So 2x minus 10 has to be less than or equal to 20 minus x. X is one side, numbers the other side. Divided by... Do I solve the inequality around here? No, why not? No, negative. No? You only swap it around if it's the negative that you divide it. There's your answer. If the question was to illustrate this answer on the number line, then you got 10 here, open a close circle, close. It says x must be less than. So it goes in the negative direction. X is less than. Okay. That was number 3. Then next one was number 7, which was the issue. Right, solve for x. What's your LCM here? 2. Not so. That's over 1, over 1, over 1. So what must that denominator be multiplied by? 2. So it's 2 into x. What does that denominator must be multiplied by? 1. So it's 1 into 5. Must be greater or equal to. This denominator must be multiplied by 2. So it's 2 into 3x. This denominator must be multiplied by 2 times this 3. It's going to give you 6. Who asked this question? Did you get that? Okay. Sorry? If you multiply the bracket out, no problem. Then it's going to be 3x plus 15 And then it's going to be, you will multiply 3x plus 15 by 2. Then you're still going to get 6x plus 30. Check there, if you're going to got at this point. If you got 6x plus 30. Do you have that? Yes, there you are on the right track. Where did you go? Do you have this, Michael? Over there?
Yes, sir.
Right. So let's multiply out, get rid of the brackets. So we got 2x minus 5 has to be greater or equal to 6x plus 6x plus 30. X is one side, numbers are the other side. So it's 2x minus 6x must be greater or equal to 30 plus 5. What is 2x minus 6x? Negative 4x. Negative 4x minus 6x? Negative 10x. Greater or equal to 35. Divide by negative 10. What's going to happen to the inequality here? Change. It's opposite. So negative 5 goes into the 7 and the 2. Right. Where did you go wrong? What's the textbook's answer? Negative? Negative 7 over 2 is negative 3.5, which is 3.5, which is correct. Alright, anybody else? Where did you go wrong? We added wrong. Okay, anybody else? We have to illustrate this on a number line. At negative 7 over 2, or negative 3.5. Is it going to be an open or closed circle? Close. Read the inequality. X must be less than negative 7 over 2. Okay? Verstaan julle? Right. Okay. Right, let's take this out. Number 9. Solve for x and illustrate the answer on the number line if x is an element of natural numbers. What are natural numbers? Natural numbers are numbers like 1, 2, 3, 4, all the way to infinity. Right, so what's my LCM here? It's 4. That's over 1. So that denominator must multiply by 4. So it's 4 into 2x. Minus, that must multiply by 1. So it's 1 into x minus 4. That must multiply by 1. 1 times 3 is 3. So what do I do now? Multiply. Get rid of the brackets. So that's going to give us 8x minus x plus 4 is greater than 9x minus 3. Now what? X is one side, numbers are the other side. So it's 8x minus 9x is greater than negative 3 minus 4. What is 8x minus x? 7x minus 9x, negative 2x. Must be greater than negative 7. That's all? Divide by negative 2, what's going to happen to the inequality? Change, so x is less than 7. They ask you to illustrate this on the number line. Let's draw the number line. So 7 over 2, remember for natural numbers is 1, 2, 3, 4, 5, 6, 7. Okay. So there is 1, 2, 3, 4, 5, 6, 7, 8. So if you're going to go with x is less than 7 over 2. Is 7 over 2 a natural number? No. The first natural number less than 7 over 2 is what? 7. So it's a closed circle at 7. In that direction. Why? It's less than. So can it be 6? Yes. Can it be 5? Yes. Can it be 4? Yes. 3? Yes. 2? Yes. 1. And there we go. The graphs, the number lines that we draw thus far was x is an element of real numbers. That is what we have drawn so far. However, this was specified for natural numbers. Therefore, I can only consider the natural number group. Okay. Yes, Michael, what's your question? Doesn't have an equal sign here. If this was, no? If the question was for x is an element of real numbers, then I would have drawn 7 over 2, open circle, and less than. Not so. But is 7 less than 7? Sorry. This is 3.5. Not so? Why am I? This is wrong. Sorry, man. So 3.5, where must I shade? At 3, then 2, then 1. That should be it. Okay, now you're talking about, should it be an open circle at 3? Is that your question? No. Why? Because is 3 less than 3 over 5? Is 3 less than 3 over 5? Yes. So it must be an open circle. You understand? If it was x is less than 3, for x is an element of natural numbers, then I would have said that's 1, 2, 3, 4. No? Then it would have been an open circle at 3. Then close. Why? Because x can't be 3. It's any number less than 3. Yeah? X can't be 3.5. Anything less than 3.5 can work. You understand? Why that is now a closed circle. Okay. Let's carry on with our lives. Now let's take us out here. Number 13, solve for x and write your answer in interval notation. I'm not going to write it in interval notation, I'm going to write it with, I'll show you interval notation. I'll illustrate on the number line and I will look at interval notation afterwards, okay? But if you know your inequalities, how to write it in inequality form, you don't need to know how to write it in interval notation. Okay, but I'll show you, because as you can see the question is saying interval notation. So I'll solve for x by taking that 3 both sides. So negative x must be greater or equal to negative 3 minus 2, but less than or equal to 5 minus 3. As you take 3 over the equal sign, positive becomes negative, same thing. So minus 3 minus 2 is negative 5. Is going to be 2. So how do I get x on its own? Divide both sides by negative 1. What's going to happen to the inequality? You change it. Swap it out. Okay, so that will become 5x negative 2. Now the proper way of writing this is x negative 2 and 5. Read this inequality here. X is greater than or equal to negative 2 and x is less than or equal to 5. Or x is less than or equal to 5 and x is greater or equal to negative 2. Not so. If you look here in this inequality, x is greater than or equal to negative 2 but x is less than or equal to 5. You guys understand? Okay. If they ask you to write this on a number line, which they didn't ask you to illustrate it on a number line. Here we'll have negative 2 and 5. You all understand why I'm not writing 5 here, no? Why am I not writing 5 there? Why am I not writing 5 there? Because our negative 2 is smaller. We will write it in ascending order. So would negative 2 have a closed circle or an open circle? closer. 5, closer. So what does this say? X must be greater than or equal to negative 2, and x must be less than or equal to 5. So that is the inequality. You guys understand? Interval notation works like this. Remember, if you have more than or less than, on your number line, it will be open circle. In interval notation, it will be a curved bracket. Okay? In inequality form, more than or less than, more than or equal to, less than or equal to. On your number line, it will have a closed circle, and in interval notation, it will have a block bracket. So maybe just add that column to your table of yesterday. Okay, so if we must write this in interval notation, then this would be x is an element. Will this be a block or a curved bracket? Block. Negative 2, 2, 5. Would 5 have a block or a curved bracket? So that is your interval notation. Okay. So you'll see me as we go through more and more examples. I will start just showing you how we would have written it in the interval notation. Do we have to? Normally they will just ask you to represent whatever. So you have a choice between interval notation or inequalities. It doesn't matter. Okay? Let's go to the next question. In 1.15, sorry, 4.12, number 15. We say solve for x if ax minus x is less than or equal to a minus 1. State any conditions that may be necessary. So what we do is we take out x as a common factor, and we leave it a minus 1 has to be less than or equal to 1 minus a. Take it over the equal sign. So a minus 1 plus a minus 1 is less than or equal to 0. So we got the common factor here of a minus 1. I'm left with x plus 1 must be less than or equal to 0. Solve for x. Nope, that's not going to work. Let's try something else. If I divide both sides by a minus 1, but there's conditions that needs to be met here now. No? Okay. So according to this, A would be less than or equal to negative 1. Eh? This is the condition that needs to be met here. Remember, this here can be simplified into A minus 1 with the negative outside A minus 1. Where that cancels and leaves you with this here. So they're asking you, state any condition. So straight away, we can say that A must never be equal to 1. Because if A is equal to 1, the sum will be invalid. Not so? Right. So if A is greater than 1, if A is greater than 1, if A is greater than 1, then let's choose 2. So 2 minus 1 is 1 over 1, which is negative 1. So that would work. If A is less than 1, let's then choose 0. 0 minus 1 is negative 1, positive negative 1. It's still negative 1. So I would say the sum has to be x is less than or equal to negative 1, provided A is not equal to 1. Okay? Because any other value will adhere to that answer there, besides 1. Well, what answer did the textbook give? Let's check it. Maybe they put it in better terminology there. What's the answer there? Let's see. Where? X is greater than or equal to negative 1 if x is less than 1. If x is less than negative 1, if A is greater than 1. If A is 1, we get x is okay. So we'll have a look at this again and make sense of what they're trying to say there. So I might be wrong here, but I'll just sit again and make sense of what he's trying to say there. Okay. Just remind me, so in a couple of days' time, I'll think about it and get back to it, okay? So for homework, I want you guys, did I give you homework on this exercise? Yes. Okay. Number 14 is very similar to that, so you'll couple those two together. So I want you guys to do all the even numbers up until 12, okay? Check your skills. I want you guys to do this for Monday. Monday is fine. So I want you to check your skills. Exercise 4.13 for Monday. It's a handy assignment. Okay? Sorry? Sorry? You told him nothing. Nice. It's on page 99. Right. So that basically brings us to the end of your equations and inequality. Your next heading, Euclidean geometry. Euclidean geometry, we'll start a new video at this point.